This week, we saw the third test of the SpaceX Starship and Superheavy booster. Once again, rocket lifting off from Boca Chica. We saw the hot staging success. We saw Starship go to orbital velocity. Didn't go into orbit, but it could have if it wanted to, and then attempt a re-entry. There was successes, there were problems, it's complicated. And so to puzzle this out, I've brought back Scott Manley and Marcus House, two people who understand rockets much better than I do. And we have a chance to sort of go through in detail what happened with the mission and what the long-term consequences are. So enjoy this analysis with Scott Manley and Marcus House. And me, Marcus, Scott, welcome back.
Hello.
Hey, how you going?
Good. All right. Well, it was a couple of months ago, and we chimed in on what happened with the second flight. Now it's time to talk about the third flight. So I guess, Marcus, why don't you let us know what the plan was for this flight? What were they hoping to accomplish with the third test?
Yeah, sure. I mean, they obviously wanted to improve on any of the issues that happened with Flight 2. You know, we had the hot staging sort of work, but then the booster broke up afterwards. So, we really wanted to see them nail that, which was amazing. We really wanted to see them get Starship to its final trajectory that it needed to get into, which is essentially orbit, but not quite. It's just a few seconds shy of that. They do that on purpose so that it'll naturally re-enter over the Indian Ocean this time, which was a little bit different to the first flight. So that was a change that sort of came in fairly last minute. Originally with Flight 2, that was coming in closer to Hawaii. Now way over the other side of the world, almost like 16,000 kilometers away or something, somewhere over the Indian Ocean. So that was a big change as well. And they wanted to leave the ship in that trajectory just in case anything didn't work out after that point for some of the other tests that they ran. So yeah, that was the goal.
That was the goal. All right.
Yeah.
All right. So now we know, and now, plans fall apart as soon as you hit reality. So Scott, let's start with the first part, like launch up to hot staging. How did that all go?
Oh, that was as perfect as it was during Flight 2. It was basically identical, other than burning for a little longer, as far as we can tell. It was. The main thing we were concerned with actually was the weather, because they had. It was overcast. There were much bigger crosswinds, and there was a lot of different winds at different altitudes. I was looking at it with my aviation weather app, and it tells you, by the way, at 3,000 feet, suddenly the winds rise to 30 knots, and so these things are concerning when you're flying a rocket up. So that being said, they did delay the launch a little, and while there was concern about weather, I think the main thing was there was people in the various safety areas, the exclusion zones, that needed to be told to get out of there. But about an hour and a half after its original planned launch time, it did actually take off, and thankfully there was actually a little bit of a break in the weather, even though there was still fairly overcast. And it ascended, went through max Q. Like, we saw, importantly, by the way, onboard video. Yes, that was the big change. We actually got live onboard video for almost the entire flight. In fact, we got almost no exterior video. So, like, during stage separation, we didn't see the engine shut down, and we saw all that from the rocket's point of view. And importantly, that meant we could see that they lost much fewer tiles during the ascent this time, which is, of course, critical to this thing surviving re-entry. So definitely improvements there, but it was very hard to tell there was much difference. Better communications, and yeah.
Yep. And the hot staging, like, we could see all the engines were turned on, everything was going great, and then it was quite well done that you saw the engines start to dial back on the booster, and then the engines come up on Starship, and then you got that hot stage, and it worked flawlessly.
Yeah, it was absolutely beautiful to watch it from onboard video. That was the cool thing.
Yeah. All right. Well, Marcus, continue the story then. We got that hot stage, and so job one was to try and have the booster do its burn back. How did that all go out?
Yeah, look, the hot staging I thought was really interesting because that all happened flawlessly. You had all the 13 inner engines fire straight back up after the separation. So, they just like with Flight 2, they came down to just the 3 engines. I suspect maybe they just added a little extra thrust, just dialed back the amount of, just added a little more thrust to those because, they probably dialed it back a little bit too much. We didn't see that. I don't believe anyway, we didn't see that sort of rapid kickback of velocity at that stage separation. So that was a really great sign. And we sort of think that had something to do with the issues with Flight 2. So that was great. Interestingly, after the boost back though, so you saw all those 13 engines firing beautifully. And after the boost back, you sort of saw them sequentially shut down on one side of the ring. But I don't know. That's interesting.
So, yeah, the jury is definitely still out on whether that was intentional, I think is what we're going to say here. And I don't think it buys that much.
Yeah. Had the fuel sloshed around and so only some of the engines were able to get access to the fuel? Or
I would think it would be pretty stable at that point, yeah.
Yeah, I think it would be more likely to be just general failures with, or just shutting one down causes, effects on neighboring engines. There's a lot of questions as to whether that was intended. But we all know that later on, when those engines were supposed to light again, they didn't.
Yeah. And so then, we saw it boost back. We saw the grid fins going. And then, Marcus, that video of it coming back down through the cloud layers was incredible. And I thought, beautiful. Okay, this is going to work. But it didn't work.
Yeah, they just sort of had the three engines sort of appeared to come online. One of the inner engines stayed lit, but then one of the outer inner engines shut down, followed by the other one. And then that was kind of the end of the feed at that point. But before that, we had those oscillations going on, the really hard rotation going on, which could have been causing all sorts of craziness with the propellant in the bottom of the tank, maybe. That's all speculation at this point, what may have happened at that point. But to me, it just felt like one of the grid fins had probably stopped working off camera. We could see one grid fin seemed to be working okay, but it was super overcorrecting and whether they were just responding too slow to keep the rotation under control or whether there was a broken one. It felt very much like that. I think it was a CRS-16 or something. It felt very much like that sort of issue. Which was that was a Falcon 9 booster that lost control of its grid fins or grid fin and couldn't keep control, and that sort of came down and landed down quite well in the end. But it seemed like that sort of problem. But it was quite violent, the booster coming down. It was coming down pretty rapidly. They don't do an entry burn like the Falcon 9 does. So that is something that's very, this is sort of still experimental stuff, and such a massive 9-meter wide booster. There's probably a few things that they need to tweak there, I would imagine.
Yeah. And SpaceX, for their credit, finally told us some actual information after the flight quickly. We learned that it tore up at about 460 meters altitude, which is pretty close to the deck. And I don't know, have they given us any more information? Do we know anything else about what happened in that last 460 meters?
I haven't heard any more. Yeah. But, there's other things. As I said, there was significant wind shear coming down. So it would have been exposed to that during the last 10 seconds or so. This thing's moving at 1,000 kilometers per hour. It's moving at Mach 1 straight down. So it doesn't take long to cover 30,000 feet. And every time it's going between different layers, it's getting wind shear. And that definitely could have contributed to instability. Talking about CRS-16 as a comparison, CRS-16 had the fins basically run out of hydraulic propellant, and so they stuck in that orientation and the thing spun up. And so fins getting stuck, it tends to spin it up in one direction or another. And that being said, there's also a lot of other interesting things that could be problematic. This is obviously going supersonic almost all the way down. And these fins, initially, they're operating inside what's, the shock cone. Basically, you're generating a shock wave, and they're generally operating inside of this. But when you have the engines light up, it changes the dynamics of the air. We talked about the Falcon 9. booster recovery as being a solved problem. And I think, well, we've proven that booster recovery isn't exactly a solved problem. It's still a very deep engineering problem that needs to be attacked and understood before it can be applied to other vehicles. And obviously, Blue Origin is going to be looking at this as well, because they're going to be doing booster recovery in the same way.
Yeah, and especially if Starship eventually is meant to be human rated, the lessons that you learn with bringing back Superheavy, you got to learn them again about wind shears and engine lighting and rolling and all of that when you've got, if you indeed have human beings. When Tim Dodd comes back from the moon, we want him to be safe. All right. So, Scott, carry on the conversation then. Superheavy is on its way back to Earth. It's doomed to destroy itself. But Starship continues on to space.
Yes. It heads down range, majestically propelled by its 6 Raptor engines, threading its way between the islands of the Caribbean on a slightly different orbit. And yeah, it successfully reaches orbit. It's marvelous. We get to see live video of this whole thing as well. And we just lose a little bit of signal here and there. And there is much rejoicing. This was, of course, like incontrovertible evidence that they had definitely made a big step onwards. And at that point, then they were looking forward to bonus points, new tests that they wanted to do in orbit. And of course, all as Starship watchers were really interested as to whether it would survive re-entry. But it was going to spend about 40 minutes in orbit doing its various things. And initially, we could see from the cameras that it was over the ocean. We could see it. There was some sort of outgassing, propellant dump. We weren't really clear. But the first test came very, very quickly, and that was to open the PEZ dispenser, open the cargo bay door. And, the space shuttle, I'm going to say it had problems with its cargo bay door, but this was a way bigger door than what we have on Starship. This first payload deployment door is designed for very thin, very flat satellites that will slide out like, a post box. And as far as we can tell, it's really hard to see how successful this was, because none of the camera angles gave us a good view showing it open. And we saw the sort of door lurch a little as if there was force on it, but it didn't really seem to move and open up as cleanly as we would like. So maybe that was a camera angle thing.
We did see all those gases coming out of the...
Yeah, and that was a view that I completely didn't understand the first time I saw it.
Yeah, that was a cool shot. The gases coming out. You could see that the atmosphere inside was sucked out.
Did you figure that out when you were watching it? Because I was not. Like, it was only in retrospect that I realized it was beautiful. Because from the camera's point of view, you could see the gases moving downwards. This was vapor or condensation inside, but the illumination was this very, very thin band of light, and because of that, it was like a 2-dimensional slice that was getting illuminated. It was like one of those laser shows where you could smoke over a oscillating laser. That was beautiful, but I didn't realize. A lot of people, including myself, did not realize that's what it was. It looked initially like a flat surface with waves on it. And we thought, oh, is this inside the propellant tank? That doesn't make any sense. But what it does actually show
is such a great view.
Of Starship, it does show that Starship does hold pressure, even if it's not intended to hold pressure. It's not explicitly vented to keep the atmosphere equal during its ascent or descent, for that matter.
Mm-hmm.
So anyway,
that's really interesting. And then they were supposed to do a test of some kind of like propellant transfer, maybe. Do we know if they actually pulled that off?
Yeah, well, it was interesting because NASA sort of had an update on their site as well. And the language they used seemed to indicate that it was all successful. They said that they completed the demonstration, essentially, but it was worded in such a way that we don't know whether it was completed entirely successfully or whether it was kind of successful. So that'll kind of remain to be seen a little bit. But I'm not really sure how they were doing that demo. We know that they were trying to transfer from the header tanks up in the nose down into main tanks and vice versa. But we really don't know what was involved in that test or how they were actually doing it. It seems to me that they were probably just using outgassing to try to add a slight gravitational sort of push to it to try to move propellant. But it was really unclear how how that was working, whether it entirely worked or not. But yeah, interestingly, I mean, there was a lot of things like that. Even the Pez dispenser door. They also said that I think the words they used on the website, I'll just bring it up actually, was that that they did additional objectives, including opening and closing the payload bay door. But, so maybe there was some stuff off camera that we didn't see because we sort of saw the Pez dispenser door sort of vibrate a little, like it had let go a little bit at some point. So it's really kind of hard to know how some of these tests went. It's very speculative at this stage.
Yeah, absolutely. And then Marcus, it continued on, and now the big question was, could it re-enter the atmosphere and survive? And it had a different destination this time. It was going to be going into the Indian Ocean and not. Oh, and that's right. There was an engine test to see if they could relight the engines in space, and they could not.
They just sort of skipped over that.
The engine test was aborted, right? It was supposed to be decided by the autonomous onboard software. And we had a countdown to it. We had no video. We had nothing special. We had somebody saying, and it's decided not to do this. But at that point, I will point out that the spacecraft was very conspicuously barrel rolling the whole time. Rolling along its long axis. So it wasn't holding attitude. And some had speculated, myself included, that it was a barbecue roll, which, I think I might have just been making excuses. I don't think that was intentional at all. No. And I think that a roll may well have interfered with the ability for it to relight its engines as well.
Yeah, well, that's pretty much the words that SpaceX had said, I think, in their statement, that due to attitude control, they had sort of skipped over that. I think they actually used the word roll there somewhere. But, that was sort of interesting in itself, really, and that's one of the main things that they're going to need to tackle in this next investigation. There's an FAA investigation on this whole thing, which I'm sure will include the attitude control issue that appears to have been the cause of some of these issues. So, I didn't see the roll thrusters firing at all. And you would think if they wanted to arrest that roll, you would have seen them because they were actually roll controls visible there on the camera. I never saw them fire, so I suspect that either they had something frozen up in those reaction control systems, or they just had lack of pressure, whatever it is that may have not allowed them to actually arrest that. But yeah, like you say, Scott, there's no way that they would have intentionally wanted to have a slow roll through that initial phase of the entry. It makes no sense at all. You're trying to make sure that the heat shield is being exposed to all of that. There was one interesting part, which maybe you've got some theories about, Scott. Just before the more heaty part of that re-entry, where the plasma really built up, it was coming in. Yeah, it was essentially coming in, just about to start coming in, ass first, as I think you put it, and that we sort of saw a heap of debris, sort of stuff coming off, and I still don't know what that was.
Right, I think that here's the thing, like debris. When you're really high up, people think that you go from being in space to entering the atmosphere, and suddenly it's all wind, pressure. But actually, it's very gentle. Like the force of that air is really gentle because it's really high up, but it still gets really hot. Yeah. So a lot of people were saying, oh, the speed wasn't dropping quickly enough, therefore this was doomed. It's like, actually, that's normal when you're this high up in the atmosphere. So anyway, what I'm saying is that wasn't blown off by the atmosphere. I think that was possibly a thruster throwing something out. A thruster that maybe was partially clogged, maybe knocked some debris. If you had, say, a thruster that was partially frozen over and then they eventually broke, the gases could go sideways and knock off tiles. That's what I think we're seeing potentially there. But it was very hard to understand what that was. It looked like there was bits of tiles in there, but it's hard to tell exactly where it came from.
Yeah, it was really odd. It's almost like there was sort of a bit of a build-up of some broken tiles that it had just been sort of stuck somewhere, and all of a sudden, just due to some extra atmospheric, stuff going on, maybe these things just let go at that point. But yeah, it was sort of odd the way it just all sort of came off in one block, and then it was like, oh, and then nothing else. It's like, that was really
we
odd.
saw that actually on the ground once. We saw them doing a thruster test, and it blew off a bunch of tiles that they didn't expect. So it's not like there's a lack of precedence here. And as I said, I think that if they had a partial blockage, it could have sent the gases in a direction they didn't anticipate. But maybe something else.
And not just like a chunk of ice or something on a cold part of the spacecraft. I mean, we see ice fall off spacecraft all the time in space.
Yeah, there seemed to be more in that than just ice. It's almost got to nearly have a look at each little individual piece to sort of see what we think they are. I mean, there was certainly some ice and some just general stuff in there that you'd expect to see, but yeah, there was sort of more bigger, chunky stuff that looked kind of black. It's like, it sort of seemed like there was a few tiles in there, but yeah, it's really hard to say.
Yeah.
So another thing,
overall, the heat shield tile actually held up really well, though. So I was really pleased with that during the whole ascent and everything. Like there was, a couple missing, but it's a really good sign to me that things are moving in the right direction.
And we also did see the fins moving, showing that they were able to continue to actuate after that whole time in space. And actually, the fins moving might be another thing which dislodged debris, because, of course, they were static through most of the flight until that time. This was not a failure of the heat shield. While there were failures in the heat shield, it wasn't the thing that doomed it. It was the complete lack of attitude control, which it had it going backwards through the atmosphere very fast. And, that would have just it would have just sliced through parts of it and melted it. And eventually the whole thing would have let go.
And those heat shields aren't going to protect you if you're being roasted on a steak, on a spit. As you're turning and you're flipping, and the hot gases are making their way around and inside. Right. Even at that beginning, it was not.
But Soyuz 5, right? Boris Villeneuve.
No.
So he was a Soyuz guy, and the service module didn't come off the spacecraft as he was performing re-entry. The orbit module did. And so as he's going through re-entry, it flips face first. He's basically getting pulled. He's facing the hatch, and he can see it starting to smoke and starting to get hot. And he's just like, this is the last thing I'm ever going to see. And you know what? I think he's taking notes. Right? He's taking notes. It's like imminent death, And then the service module came off, and it flips around, and he ends up landing. But it was a disastrous landing. But it's the same thing. Like the Soyuz was designed for one orientation. When it was in the other one, it wasn't going to last very long.
Yeah, and obviously we saw that with Columbia as well. Just how dangerous any of these gases, they can get in any nook and cranny in your spacecraft. They can do a ton of damage and tear the spacecraft apart. So, Marcus, do we know how long it lasted? Because the most horrifying thing I find with re-entry is you get those ionized gases around the spacecraft. It cuts off your communication, and you've got to wait a couple of minutes before you can regain communication once it's actually made it through the bulk of the atmosphere, and you just don't know what's happening at all. So do we have a sense of sort of how long it did survive as it was coming through the atmosphere?
Well, one point in that is that we were seeing beautiful live feeds of this quite deep into the atmosphere. And that to me was the most amazing thing of this whole mission. It seemed like the Starlinks, because there was 4 big Starlink dishes there on the nose. They were in black. And they were obviously still able to beam out that data through the plasma that it was going through, which I think is pretty unprecedented. It's probably due to the size of the ship just being so big that it's almost creating a big wake behind it that it can still beam that signal out through. So it's going to be interesting in future flights to see how long they can hold that signal through the re-entry phase. Anyway, that's kind of not quite the question, but how long did it last? I think fairly shortly, as soon as we saw the signal loss, that was the end of it. I think that it was like 48 minutes or something into the mission. and they lost both tracking from TDRS as well as their Starlinks simultaneously. So that was almost an indication that it was probably dead at that point, or at least whatever systems were connecting these things together had been severed in some way. We don't know. As far as I've seen, there's nobody that captured any sort of entry footage, like even from a long distance away or anything like that. We really don't have any clues.
Footage.
Is there? I haven't seen
satellite. Yeah, one of the I can't remember, one of those geostationary satellites caught. No, it just caught like a frame showing a cloud forming at a certain time. But I would say the fact that we lost TDRS and Starlink round about the same time, it's probably a sign that it was something, a failure in the spacecraft rather than progressive blackout, because Starlink and TDRS are operating at different frequencies, different technologies, and if they all went out at the same time, the commonality is power.
Mm-hmm.
But it was high altitude. Yeah. Like, it did not make it. Like, as soon as the atmosphere could destroy it, it did destroy it.
Mm-hmm.
So
the altitude was quite interesting, and I don't know. To me, it probably seemed to descend faster than I would have expected it to. That could be just speculation, but I would have thought that if it was oriented correctly, the way the lifting body should perform, the altitude wouldn't have dropped so much. Heading in backwards first and flipping around all over the place, it's probably hooked down a little faster than maybe it would normally. I don't know how fast the velocity was sort of getting wiped off right after the signal loss. It's kind of interesting.
It lost 1,000 kilometers per hour between the sort of initiation and the final signal. So it lost only 1,000 kilometers per hour. It was down to like 65 kilometers, I guess. And because this was a relatively steep trajectory because of the orbit, and because it was on a ballistic trajectory, it wasn't gliding, it was just spinning around out of control, it would have descended way faster than they had planned. And so the forces would build up much more rapidly. You're basically talking like a doubling of the force, the dynamic force on this thing every 8,000 meters or something. I'm not sure exactly, but I think you're talking about a half pressure difference about that. So, I don't think it lasted very long. Once the pressure got high enough, it would have just tore the thing up. It is interesting, by the way, you were talking that we got live footage from re-entry. That is an absolute, first, unique thing that has never been seen before. With Starship, right? We have this idea that it is big enough that it punches a big enough hole in the air that they think they can send a signal out through the hole in the wake that it makes. And this was possible with the space shuttle during some of the later missions. We have this problem with all spacecraft going through the atmosphere. It heats up due to ram pressure. You get these free electrons flowing around, and it creates an environment which is basically opaque to radio waves. That is the first kind of radio blackout. The second kind of radio blackout due to plasma is where your antennas are being turned to plasma, and that's what happened here.
Yeah, right. Yes. All right. So I want to give you guys both a chance, to, if there's anything else that you thought was interesting of note before we sort of move on to the consequences and what comes next. So, Scott, was there anything else during this whole flight that you thought was noteworthy?
Oh, man.
I mean, one thing that you mentioned in your video was just, and I mentioned this as well, that this is the biggest rocket ever, right? Like, even if this thing never gets reused,
payload to space.
Yeah, if this thing never gets reused,
payload, it's presumably bigger than the space shuttle. At least now we've had the space station, which is definitely bigger in terms of dimensions and mass, but it took multiple launches. The space shuttle, I think, was previously the largest things that are about 125 tons, and we expect that Starship is in that ballpark and has propellant and stuff on board. So it probably set a record for largest single thing launched into orbit. The other thing that actually a lot of people have been saying is it went into a suborbital orbit, and therefore it didn't go to orbit and shouldn't get credit, right? And I'm going to say, as somebody that did orbital mechanics, right? There's a good argument for this. So, yes, this had a perigee inside the Earth. We measured, based on its velocity, it was like a 250-something kilometer apogee and a minus 50 perigee. But what we really want to do is measure the semi-major axis, and that's simply the average of those two. So that's 125 kilometers, which is comfortably outside. The reason why you do this is if your orbit, if something that has a perigee inside the Earth isn't in orbit, that meant that the Peregrine lander wasn't in orbit around the Earth when it was out at the moon, and its apogee was out at the moon, and its perigee was inside the Earth. What really matters is the energy state of the vehicle. And the energy is simply a function of the semi-major axis, which is a function of the average of the perigee and the apogee. So this is unequivocally an orbital product. It's not like a ballistic missile where the semi-major axis would be inside the planet, right? That's my definition, and that's what I'm going to say. That is a pretty good definition. And I think Jonathan McDowell agrees with this as well. And he's the orbital police.
Right. Yeah. I mean, they could have had it go to orbit and stay in orbit if they wanted to at this point.
Yeah,
yes,
absolutely. Look, it was literally a few seconds. It's a few seconds shy of it. And, they do that very intentionally, like I said before, just to make sure that if they can't do the engine relight, which in this case they actually couldn't. They couldn't do that engine relight for whatever the actual reason was. It was probably the roll issue. And, for the most part, it's orbital. It's. I absolutely agree with that. The other really interesting thing, by the way, that I think is fairly important for people to sort of realise is that once Starship entered that orbit, it was therefore the largest vehicle, even if it remains expendable, right? Even if they can't recover anything, that's the largest vehicle that's ever been put into orbit. And, that's got the capability of putting, I don't know, somewhere between 100 and 200 tons into orbit in one hit. That's a technology that we've never had, and it's pretty much just been proven. So, in my opinion, that's an astounding thing. And, I'm certain that they will at least recover the booster like they can with Falcon 9, even if at some point they made an expendable top stage, which would actually be much lighter because they wouldn't need fins and heat shields and all these things anyway. So, that's an astounding bit of tech right there. So with the failure police wanting to call everything a failure out there in the main news media, that to me is an astounding success by itself, being able to put that mass into orbit. So we'll sort of see. I mean, we actually have to see them put mass into orbit first because this one didn't have a payload. But we know that they were dumping a lot of oxygen and things like that they wouldn't have needed to do if they had a payload on board. So
you could tuck an Orion capsule into the payload.
Oh, easily, yeah.
Area, and then have the astronauts be inside that. I wouldn't recommend it based on what we've seen so far, but it could be done. You could put the kinds of payloads that are going to be launched, say, to the Deep Space Gateway on this thing. You could put heavy satellites onto this thing. And obviously, SpaceX could send as many Starlinks as we can possibly imagine. So I'd like to sort of shift gears now. We talked about sort of how this whole flight went and sort of, and feel free to argue in the comments about whether or not this was a success or a failure. We don't think in black and white around these parts. It's all shades of gray. Scott, what comes next?
IFT-4. I mean, okay, so they're going to have to, because this didn't do exactly what it wanted, the FAA has declared it a mishap and they have to investigate. And when they say the FAA has to investigate, they in turn say, SpaceX, you have to investigate, send us a report. We want a report on our desk, before you launch again. And SpaceX,
tell us what happened.
It's in their interest to have a rough idea of what's going on, and they'll just have to satisfy the FAA before they get ready to launch. And at a certain point, though, SpaceX is probably going to want to launch faster than they can investigate these things. But I kind of think that FAA has a point where they would like you to actually know what failed last time before we let you go again. When we ground planes, we gently try to figure out why and then fix them. So there's definitely that, and I don't know how long that's going to take. But Elon has said 6 flights this year, so they better get flying again in a couple of months, right? We were like 6 months between the first two, and then 3 months here, so 2 months doesn't seem that ridiculous. But that'll be down to paperwork rather than getting hardware out there, because there's lots of hardware ready to go.
Do we have a sense, Marcus, what have they got built up in inventory right now?
They've got 4 more vehicles ahead that in various stages of completion. So that's been pretty awesome to see that. They've basically got Ship 29 that's just been tested with its. It just did a fill test last week. And so that's already been rolled back for its next phase of updates and stuff. The booster's sitting there almost ready to go, I believe. So, these are great things to see. We could realistically have one of these vehicles rolling back for more impressive static fire testing here fairly soon. But I guess the thing to remember is that with the mishap report, which is SpaceX led, by the way, these things are important to do, and SpaceX need to understand and presumably make modifications to the vehicles where there was obvious problems. The booster, whether it was a grid fin issue or some other issue, they're going to need to make updates to that or change the software that controls the entry. Likewise, the ship needs to have its various thruster controls fixed if that was indeed the problem. So, they'll probably need to make these modifications anyway while the mishap investigation's going on. I would think that, we could probably see something in May. I would assume net May would probably be a reasonable assumption at this point. I don't think that the mishap investigation from the FAA side of things is going to take too much time. SpaceX will give them that information as soon as they can, and it's not going to be like the last one, I don't think, because the mishap was much further along in the mission. They just need to nail that booster and Starship control problem, I think.
So, Scott, the elephant in the room is Artemis 3, which is going to depend on an incredibly complicated series of events: a functioning Superheavy booster, functioning Starship, a tanker in space, refueling it high teens number of times, maybe flying out to the moon, landing on the moon, returning from the moon. How do you think? Do we have any sense of how well we are proceeding down that critical path?
Well, we are not proceeding down the path as quickly as certain politicians wanted it to, but we are proceeding down that path. And I think that we're certainly more in line with a 2028 landing at this point, which is, by the way, what NASA said they originally anticipated back in 2018, what they thought it would take. I think, I think at this point, we do have, of course, a Blue Origin-led lander, and they're going to be doing their own thing for their own targets. And I think that, I don't know, while Blue Origin's lander is supposed to be for a later Artemis mission, I would be quite happy if NASA maybe changed the rules and said, whoever's ready first gets to put the first people on the moon.
Like commercial crew.
Whoever's
ready.
I don't think there should be. I think they should sort of start putting out some language that walks back the intention for SpaceX to be on Artemis 3. I don't think the Blue Origin is going to be any faster, but I think that they should at least have that possibility out there because it might motivate them. No, I think it's a really complicated thing, and I honestly, if there's any organization that could do it this fast, it probably is SpaceX. So this is all kind of moot. And the real question, the other question is, of course, what's China going to be doing in this meantime? And is that going to perhaps motivate some more political support for Artemis? Right now, we're coming out of a new funding cycle. There's been some continuing resolutions and stuff. And we've seen some of our favorite projects defunded to make way for Artemis, like Chandra Space Telescope. It's like, wow, that's gone.
Yeah, that's a bummer, that one. There's really no other way to Yeah, there's really no other way to get that data to correlate against the James Webb data. Like if you don't have the X-ray data of that hot stuff out there with the cold stuff, it's a little hard to do the correlation. It's an odd choice, honestly, because you wouldn't think it would cost that much to keep it running, considering it's up there and running. So I'm hoping that there will be some resolution to this. Yeah, I'm hoping that they'll resolve that.
Whenever they threaten this, I always offer Canada will take over. We will pay for the, I don't know what, internet building somewhere where people
downlink,
pick away on computers. That sounds like a Canada-sized budget. We'll take over that. I've been doing a lot of reporting on what China's up to, and they are hitting their milestones with clockwork precision. Chang'e 6 is getting set to go. That's going to be another sample return mission. Chang'e 7. Chang'e 8 is going to be testing in situ resource utilization on the surface of the moon. They've got 2 new vehicles being developed, both their lunar lander and their new crew capsule that they're going to be testing out with their space station. And then they've got their super heavy lift rocket. And it seems like their plan for going to the moon is relatively simple. Just 2 rockets, one with the lander, one with the capsule, go to the moon, dock, complete the mission. And all of the preparatory work is being done through all of these robotic missions, step by step by step. And they're targeting 2029, 2030. So there's not a lot of wiggle room. I mean, it doesn't really matter, right? Like NASA already had people walk on the surface of the moon. You can't ever, unless you have a time machine, you're not going to see that record.
It's NASA's game to lose. NASA can only lose. They can't. If they win, they don't get any credit. But if they lose this, then
yeah. I think the differences between the objectives, I think, is quite different. We're really trying to set up the infrastructure to be able to have a permanent settlement, and that will obviously be an objective of China's and stuff at some point. But in the near term, I think we're trying to do something much more complicated, and it doesn't really matter how you look at it. I know there was a lot of Blue Origin material a few years back that was sort of saying, unnecessarily complex and highly risky or whatever their term was, but their mission is also going to be similar. They're saying that they want to refill their Blue Origin lunar lander in a lunar orbit. You've got to get that fuel up there. That's complex. That's complex to do. And I don't know what the propellant tank, I don't know what the masses of the propellants for those tanks would be or are supposed to be off the top of my head. But you've got to get that propellant up there into some sort of depot around the or in the lunar orbit. That's a hard thing to do. So it's going to be interesting. I think SpaceX's objectives obviously very complex. One of the biggest hurdles after re-entry and reuse of these vehicles, obviously, which is probably the biggest. But the next biggest hurdle is being able to set up a propellant depot, deal with the issues such as zero boil off. They've got to solve that problem, or very close to zero. And, all these things have to be done really before they can attempt a moon landing. So, those are huge challenges to come.
Yep. Yeah, absolutely. Well, Marcus, Scott, it's always a pleasure to hang out with you guys and sort of, I don't know, armchair quarterback after these launches.
Yes.
What are you guys working on that maybe people should be interested in? Marcus, what have you got going on?
We're working on a few deep dive videos at the moment, which are coming along. But we'll be catching up and trying to dive a little deeper onto some of the Starship flight stuff and trying to understand a little bit more as the week goes on. We're doing our weekly snapshots each Saturday. So just Google my name and you'll find us.
Yeah, and then Scott, I mean, obviously it's airplane.
That's what I'm at the hangar because I've just been flying.
Yeah, of course you have.
But I'm also working on a series on nuclear thermal propulsion and nuclear electric, because honestly, this is something that keeps on coming up and we keep on not having. But more importantly, it's like less than a month to the Great America Solar Eclipse. We're all going to get out there for that.
Yep. So where are you guys going to be? I guess you're not, Marcus. You're not going to make
I'll be
the
over
trip.
the other side of the world, I'm afraid. Yeah, we don't get a good one until I think 2028. So I'll be probably heading up around Sydney in 2028 to see something very similar.
Oh, that's great. Okay.
Good. Yeah,
I'm going to
Texas. Be in Texas. So
yeah.
Again.
Nice.
Perfect. Yeah. I mean, it is going to come into Canada, but I wouldn't try like my chances of seeing an eclipse, seeing clear skies in Canada in April. I mean, it's a chance, but better to go for Texas. So awesome. Well, guys, thank you as always so much. And I guess, clear skies. All right.
Clear skies.
No worries at all. Thanks for having us on.
See you later.
Bye.
I hope you enjoyed that conversation with Scott Manley and Marcus House. I'm going to give you some sort of final thoughts, but first I'd like to thank our patrons. Thanks to Abe Kingston, Andrew Gross, Antonio Lofilara, David Giltonan, Dougie Stewart, Destin Cable, Jeremy Mattern, Jordan Young, Josh Schultz, Mark Anstis, Paul Rohrbach, Stephen Krasaki, Stephen Filer-Munley, and Vlad Shiplin, who support us at the Master of the Universe level, and all of our other supporters on Patreon. Well, it is always so much fun to sit down with Marcus and Scott and to just overanalyze what we saw with this third test. And once again, it wasn't a perfect success, but it was pretty close. I think we would have liked to have seen Superheavy survive longer before it hit the water. We would have liked to have seen Starship make it through the atmosphere successfully. And splat into the Indian Ocean. Those would have been an improvement, but still, I mean, huge progress, and this thing went to space. And I think the goal, of course, is to make a fully reusable two-stage rocket, but if it wasn't, and just you were able to launch enormous payloads into space in a fully disposable way, and as Scott said in this conversation, that, okay, maybe you start to learn how to reuse that first stage. That is still an enormous leap over other kinds of launch platforms and could already start to gobble up a big chunk of the launch market. So the testing continues. I'm nervous about how long this is going to take, only because other people are depending on their successes. Like if there was no integration with Starship and other projects, it takes as long as you need, right? But Artemis is always this looming question. Will it all come together in time so that we can see people return to the moon in our lifetime? All right. It was a lot of fun. I'm going to link to both Scott and Marcus's channels if you haven't already subscribed, but of course you have. Still. All right. We'll see you next time.